Hey guys, so today we're going to start looking at the different types of addresses in particular. This first one will be the MAC address. That's Media Access Control Address. And so let's go ahead and look at the desktop, see what we've got. Okay, here we are. MAC address, Media Access Control, is a unique 48-bit identifier. 48 bits means there can be 48 binary digits, either 0 or 1. That's burned into the network interface controller or whatever networking, and it's not networked, but networking component that you're concerned with. Network cards, switches, routers, anything like that is going to have its own MAC address. It's burned into the network interface controller by the manufacturer. Provides a network device identification unique to that particular device. So organizationally unique identifier, or OUI, is a 24-bit number uniquely identifying a particular piece of hardware from a manufacturer. This is the portion of the MAC address that belongs to the manufacturer. It's always the same for every component that this manufacturer builds. If they build network cards, if like Realtek or somebody like that, they have a 24-bit identifier. So that means half the MAC address is going to be identical for every piece of networking equipment that manufacturer builds. And they do that so that they can identify the manufacturer through the MAC address. It's the same specific, or it's the same numbers for every specific model of network controller or every piece of equipment that they build of that type. The OUIs are purchased from the Institute of Electrical and Electronics Engineers, IEEE. That is an organization that created and maintains the networking 802 family standards. And so it is the first 6 digits or 24 bits of the MAC address. Then the device ID. This is the back half of the MAC address. This is 24-bit number given by the manufacturer to uniquely designate any piece of hardware that they build. So you have a unique number, or you have a number that's the same up here for every particular model, and then you have a number that's unique. So if you got Realtek 802 network cards, right, or 777 network card, whatever model number it is, those model numbers, all the models of that particular network controller are going to have the same first 6 digits. The last 6 digits are all going to be unique. Like any other network address, you've got to have some portion of it that belongs to the host, some portion of it that designates this is a unique piece of hardware on a network. And so that's what the device ID does. It's kind of like a serial number. Each specific network interface controller is assigned a unique device ID. That's a unique MAC address for the network interface controller. It's the last 6 digits of the MAC address. All right, you got a participation activity here, another participation activity here, another participation activity here. MAC address representation, it's burned in the network controller by the manufacturer, gives each network device a unique address. That way, there won't be any conflicts on the network. It's typically representative of 6 groups of 2 hexadecimal numbers. So you've got 6 groups of 2, that's 12 doubles. It can be represented either with or without a colon. For example, DACA97C3. That would be a MAC address. Or you could use colons, you could use dashes, or you can just use plain numbers. A MAC address is not routable, but a switch uses MAC tables. So a router, you can't route a MAC address on the internet, but within a LAN or within an internal network that's controlled by a switch, MAC addresses are used to control traffic. So the switch knows the MAC address for which ports are connected to which MAC addresses. So you've got a 12-port switch. You can have 12 different things connected to it, and the switch will know on each port what MAC address is there, and so it can kind of route traffic to those MAC addresses based on the packets that it's receiving. About another participation activity or two, address table. A MAC table is used in many applications, but the main application is for routing data frames between devices on a local network. This is where what we were just talking about, a switch can use the MAC table with those MAC addresses to send traffic, to send the frames to the correct ports on the switch. A MAC address table or MAC table is a table that maps a network's MAC addresses to the switch's physical ports, kind of like a DNS server for a network. It combines the address with the physical port, and that's how locations are maintained on a local area network. It contains a VLAN number, MAC address, connection type, and the switch port number that the device is connected to. So connection type can either be static or dynamic. Static connection is manually entered into the MAC table, whereas a dynamic is learned by the switch from the first packets that the switch receives from that device. A MAC address table is used by the switch to determine traffic paths to particular devices, and by using a MAC address table, the switch reduces collisions and cuts down on congestion on the local network. It's also used IEEE 802 networking technologies address resolution protocols, which is ARP. Wireless access points and the local network's OSI model data link, for example. Wireless access points use MAC address for access control. So this is what a MAC table looks like. It tells you what VLAN the device is on, gives you the MAC address and the type, whether it's static or dynamic, and then this is the port, FA01, FA02, that's the first port, that's the second port. Then you got another participation activity, and finally a challenge activity. Once you've gotten those done, then you'll be ready to move on to the next section. Okay, guys, I hope this was helpful. If you have any questions at all, please contact me via the Canvas inbox or ask me. Technically, we won't be meeting in class. Well, yes, we will. We will be meeting in class this week. Sorry, I got my dates confused. We will be in class this week. So if you have any questions, either the Canvas inbox or ask me in class, and I will do my very best to answer those questions. Until then, have a good day.